everybody, this is going to be section 9.3, which is on the greenhouse effect. Learning objectives for today is that you can identify the greenhouse gases and identify the sources and potency of the greenhouse gases. You're going to learn for your essential knowledge some of the main greenhouse gases, the ones that are maybe a little bit more serious, the ones that maybe aren't as big of a deal. And then we're also going to learn about this idea called the global warming potential, which kind of talks about the level of greenhouse effect that some of these different molecules have. So we're first going to start by talking about solar radiation. Now, as the sun is letting off a bunch of radiation, not all of this is going to actually reach Earth's surface. So we're going to have about 26% of this is just straight up reflected back into space by clouds and atmosphere. So if you look here, kind of like it hits it, bounces off, it gets reflected back into space. And about 20% is going to be absorbed momentarily by the atmosphere and the clouds, and then it's going to be radiated off. Now, some of this that's radiated off, which you can see in the picture here on the right with the orange, some of it just goes right back into space, like the other stuff that had been reflected. But some of it, after it kind of comes in and then radiates all over the place, some of that ends up going down to Earth's surface. So the rest of the stuff that does end up going through, that's going to be what actually reaches Earth's surface, where it can either be absorbed or reflected depending on the albedo of the surface that it strikes. Now, we do not see this radiation. It's at wavelengths that we can't see, but it is going to be something that you feel with warmth. So when you feel warmth, just kind of think about how that's like the radiation that made it through our atmosphere. Now, as it gets to the surface, again, albedo is going to kind of depend whether it's absorbed or reflected. So remember that the darker and lower the albedo surfaces, they absorb sunlight. Think of how if you wear or if we think of asphalt, that's going to be absorbing more than snow, which is light, it's going to reflect it. So the stuff that is going to be absorbing the sunlight, it will then release it as infrared radiation. These lighter, higher albedo surfaces are going to be the reflecting the ones. It gets reflected, it goes directly back out into space or into the clouds or the greenhouse gases that absorb it. So that's kind of when we have the solar radiation coming in, all the different places that it can end up going. So what is the greenhouse effect? Now, the greenhouse effect gets a really bad rap sometimes, but actually it is a very natural process that is one of the main reasons why Earth is habitable. If we did not have the natural greenhouse effect, Earth would be freezing, nothing would be able to live here. So the basics of the greenhouse effect is awesome. It's when you kind of get too much of this effect that we get to some of the things that we've referenced before in this class, and we're going to get a little bit more into today. So these gases in Earth's atmosphere are going to trap the heat from the sun and then radiate it back down to Earth. And as I said, without the greenhouse effect, Earth would be way too cold to support life. So it is a good thing that we have this greenhouse effect in our atmosphere. So if you look here, this radiation that's coming down, if we look at some of these greenhouse gases, for example, carbon dioxide right here, it kind of momentarily absorbs it and then radiates it back out. Some of it gets radiated back into space. Some of it ends up getting radiated down to Earth. And this is kind of the radiation that's coming from the sun, coming from Earth. And these molecules are taking it and releasing it and kind of spreading it throughout. So when we have this radiation hitting our Earth, then it is going to hit Earth's surface. Earth then releases this infrared radiation back. The greenhouse gases are going to be absorbing that infrared radiation, radiating it back out into space and back towards Earth. Now, the portion that comes back to Earth is what's known as the greenhouse effect. If you have ever been in a greenhouse, think of how it keeps things very warm because it's kind of trapping that heat and keeping it within the greenhouse. So you can kind of think of it like that with this greenhouse effect. These molecules are going to be trapping it and sending it back, or at least the portion that is sent back is what we call the greenhouse effect. So greenhouse gases and their sources. Hopefully you are aware of some of the greenhouse gases by this point in our year with AP Environmental Science, but we're going to kind of go through the main important ones. So the most important greenhouse gases, our big one that we talk about is carbon dioxide, specifically because it is the one that is being released at really large amounts at this point in Earth's history. So carbon dioxide can come from fossil fuel combustion. It can come from decomposition, deforestation. And again, because of all of our fossil fuel combustion here on Earth, this one is getting released at rapid amounts. We also have methane. This comes from natural gas extraction and natural gas combustion. It also comes from animal agriculture. Think of the fact that the gas that cows pass is methane. And so it comes from that. And then we also get it from anaerobic decomposition. And remember that anaerobic is places where we don't have oxygen. So you can think of like bogs where we have a bunch of water. That is going to not have the oxygen is accessible. And another place where we have this happening is the permafrost permafrost thaw. And permafrost is going to be existing, remember, at like your colder areas near the poles. So when this thaws and you have that decomposition, that's going to be another place where we're having anaerobic decomposition happening. All of that results in methane. Then we have nitrous oxide. Now, I want you to pay attention. This is not the same as the NOx that we have talked about because we're talking 2 nitrogen atoms instead of multiple oxygen atoms. So nitrous oxide is going to predominantly be coming from agricultural soils, such as the denitrification of nitrate in your natural nitrogen cycle. But especially when our soil is overwatered or over-fertilized. That's where we're going to get a lot of this nitrous oxide being released. Then we also have the CFCs, HCFCs, HFC, kind of that whole group of them that we talked about with our 9.1 and 9.2 notes. And these come from sources of refrigerants or blowing aerosols in the aerosol products like we talked about with hairspray. That's where these ones are going to be coming from. Now, water vapor is also technically a greenhouse gas. This comes from the evaporation and transpiration from plants. But the reason why we kind of put an asterisk to this is the fact that it is technically a greenhouse gas. It is a gas that is going to be able to absorb that radiation and reflect it back. However, the water vapor doesn't really drive any atmospheric temperature changes because remember that water is continually cycling and it's going to be, as we get to the colder temperatures, it's going to be precipitating down. And so this is one that the temperature actually is going to result in our water vapor condensing. And so we don't just have tons and tons of water being added to the atmosphere because as it rises, it's going to end up coming back down. But it is technically a greenhouse gas. We just don't really get concerned about this one because we know it's eventually going to make its way back down and it's not just going to continue being amplified in the atmosphere. All right, so there's this thing called the global warming potential, which will be abbreviated as GWP. And this is the measure of how much a given molecule of gas can contribute to the warming of the atmosphere over a 100-year period relative to carbon dioxide. We choose for carbon dioxide to kind of be like the baseline here. And there's 2 factors that can impact a molecule's GWP. The first factor is the residence time, which is how long the molecule stays in the atmosphere, how much it resides there. And then the second one is going to be the infrared absorption. How well does this gas absorb and then radiate this infrared radiation? So again, carbon dioxide is going to be our baseline. It has a GWP of 1. And then all the other gases are going to be measured in relation to carbon dioxide. So if we look at methane is going to remain in the atmosphere around 12 years, which is longer than carbon dioxide, and it's going to absorb more infrared radiation than carbon dioxide. So if carbon dioxide has a GWP of 1, methane is like in the range of 23 to 84. It can kind of depend on the conditions where it's at in the atmosphere and everything, but it is higher than carbon dioxide. Our next one that we have is going to be that nitrous oxide. It remains in the atmosphere around 115 years and it absorbs much more infrared radiation than carbon dioxide. And this is going to be it has a global warming potential of 300 compared to that 1 that was carbon dioxide. And then the last one, we're going to have the CFCs. Those ones remain in the atmosphere for 50 to 500 years, and they absorb way, way, way more infrared than carbon dioxide does. We're looking in the range of, it can be on the lower end of 1,600, but can be up to 13,000 for our GWP. Now, you don't need to memorize these numbers. Like, I'm not going to ask you these exact numbers, but you just need to kind of know the relative levels of what we're looking at. This is why we had the Montreal Protocol to address these CFCs. Like, they're crazy high. And it's important that you know that these are all like even more than carbon dioxide. We hear about carbon dioxide so much because it is being released at like exponential rates compared to what we've seen in history. But you also need to be aware when we're looking at methane, nitrous oxide, the CFCs, that those have even more of a global warming potential than carbon dioxide does. So just be aware of kind of their relative seriousness. So this is going to be your practice effort cue for 9.3. You're going to practice the suggested skill of explaining environmental concepts and processes. So I want you to explain how greenhouse gases in the atmosphere contribute to the heating of Earth's climate. Then I want you to identify a greenhouse gas that has a GWP greater than 1 and explain why this greenhouse gas has a higher GWP than 1. So that's going to be your practice effort cue for 9.3, and those are your notes on 9.3 about the greenhouse effect.